Good morning, class. Hoping everyone can hear me, particularly those joining us via video session. Okay. Good. Well, I'd like to officially welcome everybody this fine 8 a.m. Monday morning to your first session of Interdimensional Studies and Sciences 1. And understanding that most of you are new freshmen this semester, welcome to your first class at the University of True Studies. I'm Dr. Marc Guillon, and I'll be the one guiding you, lovely people, through this session. My hope for this class is that it'll help serve as a foundation of knowledge for the remainder of your time here at the university, whether you plan on studying theoretical dimensional physics, IDT engineering, and even for the one person in here studying the history of space exploration. Diving in and getting started, a short class summary and all the information available on these slides should also be available in the syllabus provided to you in physical form if you showed up today. It is also available online via the class portal if you are joining us via video. Classes will be held bi-weekly, in person, and streamed via the school's class portal. Major topics of this class will cover the history of the single universe multidimensional principle, the foundation of dimensional physical sciences, and an overview of Gray Harrison's space travels. I know you're all excited for that. The required materials for this class will be McCraw's Foundations of Dimensional Reality, version 7, as well as a copy of Gray Harrison's First Expeditions, ideally the 12th edition. Both should be available at the school's bookstore in physical and digital formats. My personal advice, if you want to save a couple coins, interplanetary versions are available online, and they're cheaper if you don't mind them being in black and white. Moving forward, here are some grade breakdowns for the semester. Take a quick look. These are also available in the syllabus if you want to study them in detail. Note that the term paper and final exam combined will amount to over 50% of the final grade. No curve will be applied to this class. Now let us open with a quote from one of the principal founders of the field of interdimensional physics, Dmitry Kuznetsov, who we will study in greater detail this semester. He stated, "I am finding it increasingly difficult to find a meaningful distinction between a world unreachable and a world inexperienceable." The opening quote is from his autobiography, where he touches on a fundamental notion in interdimensional studies. That is, what is considered to be beyond the norm of what we know the universe to be is limited to our own human knowledge and limited to our ability to perceive how the universe works. These limitations allow us to define parts of existence that we cannot immediately understand as a separate type of existence to be defined and studied as interdimensional physics. Now getting started, let's go over a couple definitions to help us set a foundation for this class. A dimension, as defined for our purposes, will be considered the range over which, or the degree to which, something extends and can be measured. The observable universe is a region of space that humans can or theoretically observe with the aid of technology. Space will be defined as a boundless extent in which objects and events occur and have relative position and direction. Light speed, as I'm sure you're all aware of, is the universal speed limit. Its speed in a vacuum being 299,792,458 meters per second. Quantum physics is an important pillar stone in our field and is defined as the branch of physics that deals with the behavior and motion of subatomic particles. Time in physics can be thought as the measurable change in an interval in which said interval occurs. Interdimensional in our studies will be defined as an event or an experience that occurs between 2 points in space that are otherwise unobservable to each other. More clarification on this concept to come. Interdimensional travel is considered to be the movement of mass or energy between 2 points in space moving apart from each other faster than the speed of light. Spacetime, a unifying model, describes how a coordinate can be placed within 3 dimensions of space and 1 dimension of time. All these definitions will come into play throughout the semester. We'll delve much more in detail on each one of them as we go on. And I'm hoping that this first session can just serve as an intro to these topics. Hubble's law, another important pillar stone in our field, describes how objects in space appear to be moving away from Earth at speeds proportional to their distance from Earth, meaning from our viewpoint, objects closer to us move away at a slower speed than those further away. An intrinsic universe, which is how today's physicists view the nature of the universe to be, is a concept in which the universe contains all of existence within itself. There is no boundary or edge, and there is no concept of outside the universe. Cosmic expansion, which we'll discuss extensively in this class, is the experience of the distance increasing between 2 points in space not bound by gravity. Please see, as the universe is intrinsic, there is no space that the universe expands into, but rather it expands into itself. Okay, I know. The human mind did not evolve to be capable of truly picturing a lot of these concepts. But the mind is capable of being made to understand that even if we can't envision something, does not mean that something doesn't exist. A fun mental exercise for you all to practice during your next 4 years here. Moving on. We will begin with going into a little bit more detail on the idea of an observable universe. The observable universe is everything that is observable to Earth, which is limited intrinsically by the speed of light. As light travels through the vacuum of space, whatever body that light has been emitted from is visible to us as it was when the light first left the object. Depending on how long it takes that light to reach us, we may see an object as it was milliseconds to millennia ago. Therefore, the boundary of the observable universe is expanding at the speed of light, meaning that every year the observable universe grows by 1 light year, or about 9.46 trillion kilometers. There's a couple other data points concerning the observable universe that will take a second now for you all to write down. Okay. Objects outside the observable universe may become part of its boundary as the observable universe expands. And we should note that there are in fact infinite observable universes, each based on a central reference point. The observable universe, as seen from Earth, is usually identified in scientific circles as OU prime. However, due to Hubble's law and the expansion of space in the universe, some objects outside the boundary of the observable universe will never become visible to Earth, as they may appear to be traveling away from Earth further than the boundary expands. It's important to distinct that this speed is apparent and not a true measurement, but our perception of a combination of factors that allows an infinite but self-contained universe to expand at varying rates. Now, getting into the dimensional part of our studies, using this knowledge, we can find ourselves at Dr. Kuznetsov's single universe multidimensional principle, the principle of which all dimensional studies relies upon. 2 or more observable universes centered at points in space which move apart from one another at a rate that is perceived to be faster than the speed of light in a vacuum may be considered to exist in separate dimensions relative to one another. This principle is bound by 3 main tenets. 1. 2 points in the universe may never become observable to one another due to the expansion of space. 2. All laws of physics need not be consistent across a self-contained universe. 3. Due to the limitations of the speed of light, travel between 2 points moving apart from each other in space may never be possible. In this, Kuznetsov proposed viewing observable universes that will never be observable to each other in any form is a practice in being separate dimensions. Dimensions, in this line of thinking, exist not in absolute terms, but rather in reference to one another. In this example we see here, we have 3 universes. OU1 and OU2 are considered to be separate dimensions in reference to each other. We can, however, define an observable universe, OU12, between OU1 and OU2, that would not be separate dimensions in reference to the other 2, creating in effect a continuum of increasingly different dimensions, a concept that we will delve into much greater detail in future lectures. And with that, we're running towards the end of today's class. I'll let you guys out a couple minutes early considering it's your first day. Next time, we will be discussing the basics of quantum entanglement and a history of the first attempts of interdimensional travel. There won't be any assigned reading for this upcoming week. Don't get used to that. And I'm hoping to get to know you all better over the course of the semester. Have a good rest of your day.